Welcome to the DIY Honda Garage channel. The DTC P2649 indicates a high voltage condition in the rocker arm oil control solenoid circuit of a Honda Civic from 2011 to 2015. This issue usually affects the operation of the rocker arm oil control solenoid (RACOS), which plays a key role in controlling the engine's variable valve timing, allowing for optimal performance and efficiency. The solenoid is typically located on the cylinder head, connected to the engine control module (ECM), and responsible for regulating oil pressure to the rocker arm assembly. A high voltage condition can suggest either an electrical fault or a component failure that prevents the solenoid from functioning as intended. The issue can lead to performance problems, including reduced engine efficiency, erratic valve timing, and increased emissions. Therefore, timely and accurate diagnostics are crucial to prevent further damage or operational issues. The rocker arm oil control solenoid is a vital component for managing the engine's variable valve timing. This solenoid regulates oil flow to the rocker arms, allowing for adjustments in valve lift as needed based on engine conditions. Its role is to optimize engine performance by altering the timing of the intake and exhaust valves, which directly affects efficiency and power. Normally, it is mounted on the cylinder head and connected to the engine control module, ECM. The occasional high voltage error, as indicated by DTC P2649, means that there may be too much voltage supplied to the solenoid, which could impact its performance. If the control solenoid is not functioning effectively, it could lead to poor fuel economy and increased emissions, necessitating thorough diagnostics to pinpoint the issue. Several potential causes could lead to the P2649 DTC code being triggered. A common cause is a faulty rocker arm oil control solenoid itself, which may not be functioning properly, leading to incorrect voltage readings. Another potential issue is wiring related, particularly poor connections, corrosion, or damaged wires, leading to either an open or short circuit. There could also be issues with the engine control module, ECM. If the ECM has outdated software or is defective, it may not effectively control the solenoid's operations, leading to incorrect voltage outputs. Each of these causes needs methodical testing to ascertain the source of the problem before proceeding with repairs. Symptoms associated with DTC P2649 can be quite noticeable. A significant symptom is reduced engine efficiency, as the high voltage condition may prevent the rocker arm oil control solenoid from adjusting valve timing properly. This can lead to increased fuel consumption. The check engine light will typically activate, alerting the driver to a potential issue with the vehicle. Additionally, drivers may experience erratic engine performance, including unexpected hesitation or rough idling. These symptoms collectively indicate a need for immediate diagnostic attention to prevent potential further damage to the engine or emission system. In the first step of troubleshooting the P2649 error code, start by turning the ignition switch to the on position without starting the engine. This allows the onboard diagnostic system to begin its checks. Following this, use the Honda Diagnostics System, HDS, to clear any existing DTCs. This may help reset the system and provide a clear indication of current issues. After clearing, start the engine and hold the RPM at 3000 without any load until the radiator fan activates. Then let the engine idle. This process will help in verifying if the DTC reappears. If DTC P2649 shows again, move on to the next step. If not, you can conclude that the issue may be intermittent and check the connections and terminals related to the rocker arm mechanisms. The second troubleshooting step involves examining the rocker arm oil control solenoid's internal resistance. Begin by turning the ignition switch to the lock position to ensure safety while working on the vehicle. Next, disconnect the rocker arm oil control solenoid 2P connector, which prevents any power flow and allows for an accurate resistance measurement. After that, you'll measure continuity between test points 1 and 2 of the solenoid side. Ensure the ignition is in the lock position and that the connector is disconnected. A proper resistance reading should fall within the 14 to 30 ohm range at room temperature. If the resistance is outside this range, replacing the rocker arm oil control solenoid is necessary to restore functionality. Proceed to the next troubleshooting steps only if the reading falls within the specified range. In the third step of troubleshooting, the focus shifts to checking for continuity along the PG1 line. Begin with ensuring that the ignition is in the lock position and the rocker arm oil control solenoid 2P connector is still disconnected. Check for continuity between test points 1 and 2, as specified in the diagnostics. Test point 1 should be the number 2 pin of the solenoid's 2P connector, and test point 2 should be a body ground. Establishing continuity confirms that the wiring is intact and no breaks are present that would prevent proper signal transmission. If continuity is confirmed, you can proceed to the next step. If not, it indicates that there is an open circuit that needs repair in the PG1 wire. The fourth step involves examining the VT Sol in line for any potential shorts. Start by jumping the SCS line using the HDS to ensure that the system is in the correct diagnostic mode. Next, disconnect the ECM connector B49P to prevent any interference during testing. You will then check for continuity between the VT Sol inline at 2 designated test points. Test point 1 should be the number 33 pin of the ECM connector, which is typically green GRN. And test point 2 should correspond to number 1 of the rocker arm oil control solenoid 2P connector. Establishing continuity means that the VT Sol in wire is functional. If continuity exists, ensure that the ECM has the latest software. If not, update it or substitute it with a known good unit. If there is no continuity, repair the open wire in the VT Sol in circuit. Once repairs are completed, it is essential to ensure everything is functioning correctly. Begin the final verification process by reconnecting all connectors that were previously disconnected during diagnostics. Once everything is back in place, turn the ignition switch to the on position and reset the ECM using the HDS. This reset clears any fault codes and recalibrates the system. Then start the engine and again hold it at 3000 RPM without any load until the radiator fan comes on, allowing the system to stabilize. This procedure helps check if DTC P2649 reappears. Finally, check for any pending or confirmed DTCs using the HDS. If P2649 is indicated, further investigation into poor connections or loose terminals is required. Otherwise, troubleshooting is complete if no new codes arise. To prevent the recurrence of DTC P2649, it is recommended to follow a regime of preventive maintenance. Regularly checking the wiring harness for wear, corrosion, or loose connections can preempt electrical issues that trigger the error code. Ensuring that the ECM software is kept updated is essential for optimal operation of the vehicle's engine management system. Manufacturers may release updates that rectify known bugs or improve functionality, including how the solenoid operates. Additionally, regular inspections of the rocker arm oil control solenoid should be conducted to ensure it maintains its full range of function. These proactive measures can save significant time and expense by averting major malfunctions in the future. In conclusion, the DTC P2649 serves as a critical indicator of problems within the rocker arm oil control solenoid circuit. Understanding its implications allows for targeted diagnostics and repairs, particularly focusing on electrical tests and component checks. Timely identification and resolution of the issue can prevent performance drops, increased emissions, and more extensive engine damage. It is essential to follow the detailed diagnostic procedures meticulously to ensure that no potential causes are overlooked. Regular vehicle maintenance and monitoring can significantly enhance the reliability of the vehicle and minimize future occurrences of similar DTCs, ultimately fostering a smoother driving experience. Please like and subscribe to the channel. See you next time.